and this is the Vic Academy, and today we want to look at integration. Integration is one main part of calculus. Calculus is divided into two. That's one is integration and then differentiation. So differentiation comes first, then we have the differentiation, which is called integration. So today we want to look at integration, and if you have any question or comment, leave it down on the comment box. Remember also to share this with your friends, and remember also to subscribe to this channel so that every time I post anything or you have a question in a mathematical field, you can leave it like a comment and be able to check it out and guide you on. Remember, we do this because we love mathematics. So if we let a given function fx to be if we let fx be continuous on a closed interval b, and we have gx which is continuous on mb, and it happened that the gx is same as fx for ab x in mb, then we'll say that we'll call this g, we'll call it a derivative of f. Yes, so it's called the derivative of f. So the process of solving the derivatives, I think I should be using another color like orange. Yes. So the process of solving derivatives is called the differentiation. And the differentiation is actually what we call integration. And this is now our discussion today about integration. We use the one we normally use this symbol here to denote integration operation. So we mean if we integrate this, so this is a derivative of fx, then we expect to get gx plus a given c, and this is the integral of fx with respect to, in short, with respect to, we take w, r, and t becomes with respect to x, where c is arbitrarily constant of the integration. Generally speaking, we say the derivatives of a given xn is given by this, which will be same as taking the x, you do this n, you add 1, then you divide with this power here, then plus c. You should make sure that this c here, this n here, is not equal to -1, because if it's equal to -1 here, then this becomes 1, because we know that then the power of 0 is equal to a given 1. So because we know that, that's the reason I'm giving out this condition here. Okay, let's see what this is going to happen. So in this case here, we are saying we need to identify our n, which in this case is negative 1/2. So what we need to do here is to get n plus 1 which is same as negative 1/2, then we add 1. So this is giving us positive half. Okay, so if we integrate this one, we can see clearly, from our general equation that you have just said there. You can see now our integration for this will be x, okay, power half, okay, power half over half, because our n plus 1 is half, which gives us, okay, then from this one we add a constant c. So this one will mean this is like 2x power half plus c. So this implies that the antiderivative or the integral of this, the solution to this is actually 2x power half x plus c. Okay, so we have to note something here, that we have two types of integrals. We have what we call infinite integral, and we have what we call definite integral. If it happens that your integral or integration or derivative is open, so you see this one is indefinite. But if it is closed to a given interval, like an interval a and b, then we say that integral is definite integral. Kindly note that. Okay, now let's move to a very key important thing here, and this is what we call standard integrals. We call it standard integral. These are just so this means you identify get its square root, such you are going to get your s square to x and o square to a square, and therefore you get this. So this is what we mean. This is what we mean. Okay, So let's look at an example here. You come across this kind of question whereby you are told to get the integral of this kind of equation here, this problem here, plus 25. Let's just start with the basics. So dx, of course. So we are saying, using the first form, standard form of integration, we need to identify here. You want to identify here our x squared, because clearly you can see this form now. So you can see this clearly. Our x squared is x squared, and therefore a square root for this one, that we get x. Square root for this one is actually x. So that's just divided directly like that. Then our a squared, okay, our a squared, in this case is 25. Okay, so in this case here, our positive a is actually 5. So this tells us that if we can now use our solution to this kind of standard integral, then we will have 1 over okay. So here we expect to have 1 of 5 tan, okay, x over a plus c. Okay. So this is what you have in here. Okay. We can look at another example. Okay, a bit complex one. So we have here 1 over 3x squared plus 16. This is over dx. So we are saying this one is equivalent to integral of 1 over a squared I mean x squared plus squared sorry, dx. Okay, dx. So this means we have some things here to note. This one and this one. Remember, we need it to be this form. So for it to look like this, we need to divide by 3. Is how we can factor out this one. 3 here, because we need coefficient of x squared to be 1 here. So this is what we mean. You have to do something here, because so this should be yes 1, or this over, and given 3 we factor out 3 because we don't want to see 3 there. X squared, okay, plus of course this wouldn't be 16 over 3. Okay, so as well you know that know this tells us that the 1 over 3 can come outside the integral, so that we have now 1 over x squared plus 16 over 3. So we are trying to modify our integral to that, so that this part here, we have to make it look like this to have our a squared. So what should we do? So if we can write this one, then we have 1 over 3 the integral of 1 over x squared plus, this is like 4, we all see that, over square root of 3, so that this one can put to bracket square, okay, dx. So this one from here we are perfectly able to see our a being being 4 over square root of 3, and clearly we can solve our integral, and then what we'll have in this case, it will be remember there is 1 over 3 a constant outside, okay, which will be times integral, this 3 will multiply the a, 1 over a, which is reciprocal of that, root 3 over 4 tan tan inverse of x of over a, which is will become root 3 over 4 x plus c. So clear, you can see this. So it's like over 12 12. Doing this okay. It's okay. So that is like that, and basically that's how you play with it. So in case you have a given quadratic expression, because I like leaving some questions, some work for us to discuss, but let me leave it like that, so that in case you have a question, you leave it like a comment. Okay, so until next time, that's bye.